I have the extreme pleasure of announcing all these wonderful guest speakers. The guest speaker that's coming up, Chris Anderson, in a few moments, is the former editor of Wired Magazine, and he left Wired to focus on his UAV manufacturing company using some extraordinary technology with 3D robotics. So I'm not going to waste a lot of time. He has an exciting program. Let's give a warm welcome to Chris Anderson.
Good afternoon. Hello? Testing, testing. Does this work? Okay, we're just gonna crank it up a little bit. Can you hear me? Yeah. All right, good. Thank you. It is a pleasure to be here. This is my first AMA show, and this is all new to me. I want to tell you a little bit about sort of my own, why I'm here, how I got into this, where I think it's going, and how what looks like a hobby today may be a massive industry in America, and the sky could be dark with these things, what the commercial applications might be, where the technology is taking it, and why I quit my job of being editor, Wired, last month to make this my full-time gig. Just let me just start with my own kind of personal story. 5 years ago, I have 5 children, ages 4 to 15. And I'm constantly trying to get them interested in science and technology. And just failing and failing and failing again. And then Lego came out with Mindstorms 2.0. And they sent me an early copy, and I decided to do something with it. And so we built the traditional 3-wheeled tribots, and the children were unimpressed. And then we built the walking thing, and they were unimpressed. It turns out that it's very hard to impress children with robots, because they've seen Transformers. And what Hollywood can do with CG is actually, impossible in the real world. So I could not think of any way to get them interested in Lego Mindstorms. And then meanwhile, somebody had given us this radio control plane, and we didn't know anything about RC, and we took it out in the field, and we flew into a tree. And they were also unimpressed by that. So I thought, what might impress the kids? What might interest them? And I thought, what if the Lego could fly the plane? And so we came home on the dining room table, and there you have, 5 years ago, the world's first Lego autopilot. That is those little sensors, and it comes in Mindstorms, are really cool. They've got gyros and accelerometers and magnetometers and Bluetooth that allow you to connect with GPS. And so I knew nothing about this. I could barely spell autopilot. But I did know that, if I Googled around a little bit, I'd find out enough to put this together. So that is a Lego autopilot. And we put it in a plane, and it actually worked. And this is now the world's first Lego unmanned aerial vehicle, UAV. It's in the Lego Museum in Billund. I would say that it did, when I say it worked, what I mean is that it's still in one piece. It was a pretty terrible UAV. It turns out that for various reasons, Lego's a little bit big, it's a little expensive, it doesn't have the right resolution on the sensors and all this kind of stuff. However, that was the beginning of my sort of journey into what led me here. The children, by the way, lost interest like 10 minutes later. And I went right down the rabbit hole. And I started just looking around to see what was available. And there wasn't much. There were commercial autopilots that were like $5,000, $10,000. But there really wasn't very much that seemed accessible. And it's like, how is it possible that I know nothing about this, and my kids and I put together a Lego autopilot, and yet you can't find one out there for $100 or $200 or that sort of thing. So because I'm a web guy, I kind of grew up and tend to do things online. I said, well, clearly I've got a lot to learn. If I'm going to learn, I might as well learn in public. So this is this notion of share your ignorance. So I just created a website called DOI Drones, and I started sort of being stupid in public. I asked dumb questions. I would find things that everybody else already knew about but were new to me. And it turns out a lot of other people were interested. And today we do more than 2 million page views a month, 33,000 registered members, et cetera. So it's actually become one of the biggest robotics communities in the world, all because a lot of people were thinking about the same thing at the same time. Now, why is it happening now? Why is it 5 years ago? 6 years ago, I could find nothing. Now there's tons out there. But what triggered this? And the answer is in your pocket. What's triggered this sort of notion of personal UAVs is the smartphone revolution. in your pocket, if you have an iPhone or an Android or any kind of smartphone, is the fastest accelerating technology the world has ever seen. What's going on here, inside your phone are sensors. They're called MEM sensors, microelectronic mechanical devices, but they're basically chips that are gyros and accelerometers and magnetometers and GPS, et cetera. But these chips do functions that used to be mechanical, $1,000 military things before. A gyro used to be like this. You'd have to it takes two hands to hold it. And now you get gyros, accelerometers, and magnetometers, all three of them each. So 9 sensors in total on a chip the size of your finger. That's what the Apples and the Googles are doing, and what's going on with ARM processors and GPS and cameras and memory and wireless. All this stuff has incredible application outside of phones. And our discovery was these make for great autopilots. So if you look at this happens to be one of our autopilots here, APM, but when you look at it, it's basically just smartphone components laid out in a different way using different software. And that, to first degree of approximation, with the right app, you could fly a 747 with your phone. Not very well, and I wouldn't recommend it, but you basically have what you need to do a flying robot in your pocket already. And because of the economies of scale of the Googles and the Apples of the world, these things are falling in price and increasing in power at a rate we've never seen in history. So all those quadcopters you see out there, those weren't possible 10 years ago. And now they cost like $30. That's all because of the spin-off technologies of basically the mobile revolution. And that's why it just so happened that 5 years ago was the right time to get started. So we got started with our own autopilots, and again, we knew very little about this, but we in the community, it's an open source community, we just started combining ideas, and we came up with the first one. It's based on the Arduino open source hardware program, platform. And we just started putting these chips on, and this was our first autopilot. And today they look like this. And these are a little box that you put in any RC vehicle, and it turns it into a fully autonomous drone. You can put it in an airplane. You can put it in a multi-copter of any sort. You can put it in a traditional helicopter. You can put it in a car. You can put it in a boat. You can probably put it in a submarine. We have not yet tried that. But the notion of a universal autopilot is really what we set out to do. And when I say we, I mean a community of thousands. This is created by largely volunteers online. The company I've just joined does the manufacturing. We have pick and place lines and CNCs and big factories. But fundamentally, the code, all the smart stuff, is created by people just like you. Just people on the community whose day job is, some of them work for Google and Apple and Microsoft and IBM, and some of them work for banks in Japan and advertising agencies in Brazil, or they work in a grocery store. But this is their passion, and because there's so many of them and there's a place for them all to contribute, they collectively have done something that was essentially 10 years ago a kind of a Boeing, Lockheed kind of technology, military industrial stuff that cost tens of thousands, hundreds of thousands, even millions of dollars, is now basically a little plastic box that you can buy for $170 that is open and can turn anything into a mobile robot. That's the power of the web's innovation model. That's the power of the smartphones technology platforms. And that's what's possible today, and that's why I'm here, because it was just kind of mind-blowing. Like, not often in my life do I say, holy crap, is that possible? Could I do that? And this was just one of those things, but around the dining room table with my children, I had one of those kind of jaw-dropping moments. This is sort of what they look like on the inside. This is one of our latest ones. This is done with the ETH, which is a Swiss university, is our partner. This is designed to be put in an AR drone and turn the AR drone into a real drone. And it's just, that level of systems integration, what you're seeing there, that's being done by a team of 26-year-olds who, literally 3 years ago, had a soldering iron on a dining room table, and now they're running these robotic manufacturing facilities. How is it possible that these kids, who are all, by the way, from Tijuana, Mexico, how is it possible that they're producing this kind of electronics? And the answer is, it's really getting easy to do manufacturing right now. They basically went on eBay. They searched for a pick and place machine. They found a used one. They downloaded the manual from Google. And now we're running ISO 9001, production lines And like none of them, like my co-founder, Jordan Munoz, hasn't been to college yet. And this is just what's so exciting about this moment, that the web has allowed hard things to become easy, and people who know nothing to get really smart really fast, and for communities to come together to do the kind of stuff that it used to take massive aerospace companies to do before. So what we see is an opportunity to basically, as I say, take military-grade technology and make it available at toy prices. Drones right now are associated with weapons and privacy invasions and all sorts of scary military stuff, predators and global hawks, etc. But I can imagine a day where you drive around here in farm country and you see robot crop dusters overhead. You go to the beach and windsurfers are followed by drones with cameras. That the sky could be dark with these things. I have no idea why and what we'll be doing with them, but what I do know is that the technology is getting cheap and easy enough so this could be possible. And just to look at this list of things, you have personal drone. So, 50 years ago, computers were mainframes, and then Jobs and Wozniak said, well, and Gates and Allen and others said, what about personal computers? What about computers on your desktop? And it changed the world. And when you add personal to industrial technologies, what's important is not that they're cheaper and easier, is that they get in the hands of a different class of user. And to sort of, the internet used to be a military technology, and now we all use it. We don't think of the internet as being a weapon anymore. We don't think of it as being Defense Department stuff. And I think the same thing's going to happen with drones. I think we're going to think of drones as being something that's useful, something that's personal, something that we see commonly, and it doesn't freak us out. Now, we're not there yet, but that's our ambition, to sort of demilitarize drones, to destigmatize them by simply making them cheap and easy and available. Look at that word, disposable drone. Now, the military doesn't think about disposable drones. These things are considered top secret. When they fall behind military lines, they send like a Humvee to retrieve them. They're super classified. And we're like, but what if they cost $50? If a disposable drone, what if you sent out 100 and 80 came back? But the mission was accomplished. You got the imagery you needed. Or what if, if they're disposable, if they're not intended to come back, it doubles the range, right? They just go out, the battery's exhausted, they fall on the ground. What if you drop them from planes to get close-up views of things? Disposable is not something a military-industrial complex does very well, unless it comes to meals or ammunition, especially not when it comes to aerospace. And when you think of these things as basically just, toys with kind of, super smart brains, then you can think about disposability as a feature. And that cost dimension is something that the defense contractors of the world don't really explore, but communities explore really well. So this is what happens when you get this box. When you buy this box, the first thing you do is you download the software, and it says, what would you like this box to be? Would you like this box to be a robot car controller, a robot plane controller, a traditional helicopter controller, or any one of these multi-copter configurations? You just click on one, and now this box becomes an autopilot for that kind of vehicle. And this has really never existed before, the notion of a universal autopilot. And it's just simply possible because it's an open platform. And people who know something about every one of these contributed to the code to allow it to do that one thing well. That again makes, in the same way a personal computer was a general purpose computing device. It could be a video game device, or a spreadsheet device, or an email device, or a phone device, depending on the software. We think the same thing is possible with an open platform for robotics, in this case, APM. When I say drone, I mean fully autonomous, right? You can fly at RC if you want, but that's not what it's there for. This is the mission planner, and what you do is you just click on the screen and you give it waypoints, an unlimited number of waypoints, by the way. Oh, did I mention it's all free? All the software is free. It's all open. And each waypoint can have scripted, can have commands. It can be a takeoff or a landing or loiter or keep the camera on something or switch altitudes. You can just sort of click on all the points and do the mission that way. And then when you're done, you just say go. It takes off, does the mission, lands by itself, and then you just do what you want with the imagery. Or you can even, if you want, script it with like Python and do it, super complex stuff. But the point is, it's autonomous. You can fly it if you want, but that's not the point. The point is it flies itself. And not only that, but you can have multiple ones in the air at the same time. So on the military world, the drones, it's like 30 people to operate one drone. We think one person ought to operate 30 drones, or maybe 300, or maybe 3,000. But that's what autonomy allows us to do. And you know, when you look at swarming and you look at clouds out there, just imagine the entertainment potential of drones as pixels in a 3D floating screen. That's what gets possible when these things cost just tens of dollars rather than tens of thousands of dollars. Here, you know, one thing we take really seriously is safety and sort of using them as an aid to RC modeling. Right now, when I'm a terrible pilot, and my children are much better than me, but as I was teaching them, we crashed. We crashed a lot. And so what we introduced was the notion of what's called a geofence. So a geofence is a three-dimensional box, and you just sort of say, this is the box on our field, the aircraft cannot leave the box. So you basically define the box there, you decide, and you give it a center point, and this is a data log of what happens. So basically, every time it hits the edge of the box, it takes command away from you when you're flying RC, flies back to that return point, and then gives command back to you. So if you can give a controller to a kid, and they can just like slam the stick forward, try to crash on the ground, the moment it leaves the box, poof, snaps back into you know, autonomous control, goes to the middle, and then loiters, waiting for you to take over manual command as well. That, you know, just think of that as a training tool. You can't go wrong. It's an uncrashable, you know, aircraft. And that includes both airplanes, multicopters, and traditional helicopters. As you heard, I mean, I didn't come from the RC world. I got interested in this through robotics, and I actually know very little about RC. But what I do know is that when we want to introduce this to millions of people, and we think that RC is just too complex right now. You know, to understand receivers and transmitters and servos and the connectors and all this kind of stuff, it's too complex for most people. What people want is smartphones, and they want tablets. And so the interfaces going forward, because these are autonomous, by the way, a tablet is a terrible way to fly an aircraft. I don't know if you use an AR drone, et cetera, but it's a bad interface. Tilting it, moving it in fingers, et cetera. But if you're not flying it, if it's a programming interface, a tablet's great. So this is a ground station that supports our autopilot. It's called Mavilis, and that's it rendered on an iPad. And when you realize that you go to the field and like imagine a Hollywood filmmaker. You've got a set. Right now that camera's on a boom, and there's a boom operator who moves it around, or maybe it's a manned helicopter, and you need professionals doing it. What if instead the cameraman could take out his iPad, look at an aerial view or just a three-dimensional view of the set, and then just trace on a finger the path that the camera should do. So it should go out 400 feet, then kind of swing around and zoom in, and then stay 5 feet away from these two actors as they're talking with the camera focused, and then just kind of swing around and capture the scene. That's a hard thing to do with a boom, especially getting out the 400-foot bit. It's a hard thing to do with a manned helicopter, getting that close to actors, but it's an easy thing to do with a drone. And so using a tablet as an interface allows people who don't know how to fly, who aren't experienced with robotics, to basically not worry about it. Don't control the drone, control the camera. What do you want the camera to do? Let the autopilot do the work of figuring out what that means. So we think that mobile interfaces are definitely the way to go. This is a product that we're going to be releasing early this year. It's called a Follow Me box. So how many people here have a GoPro camera? Great. Okay, so you know how cool GoPros are and what a revolution they've been in sports video. That windsurfer, it's actually really hard to get a good shot of a windsurfer because, first of all, they're away from the shore, and second of all, you kind of want to be from an aerial altitude. You want to get that top-down view. So what we're developing is a box that a windsurfer or a kite surfer or whatever would have on their belt, and when they're really kicking it, when they're really doing well, they would push the button, and the multicopter would come up, take off the beach, and then position themselves right 30 feet above, 30 feet behind the windsurfer, and just follow them as they do their thing with the camera trained on them. And when the battery gets low, it flies itself back to the shore. That's not actually the box. That's a prototype. We're using Raspberry Pi as the underlying platform. The actual box will be waterproof, needless to say. But that's the kind of function that you don't think of drones being personal video droids. You don't think of drones being extreme sports. You don't think of drones on the beach. But I think you're going to start to see that stuff more commonly. You can already start to see them in the Bay Area where I live. So that's another kind of surprising example that came out of the community. By the way, it has been done by some other platforms already. We'd like to release this as a product, that the box is something you can just buy and press the button when you're ready. I want to talk a little bit about the structure. As I say, we started with a website. The website became a community. The community became a development team and a collaborative effort. And then it came time then people were like, this is fantastic, love the designs, et cetera. But the designs were basically, here's a printed circuit board design that you can get fabbed, and here's the components that you can buy from DigiKey, and here's like how you solder it together, and it was just way too hard. So the community said, well, you just make it for us. We just want to buy this stuff, right? We don't want to buy circuit boards. We want to buy boxes that you just plug in. So we created 3D Robotics as a company to serve this. And this is largely the structure. We have a nonprofit side, which is the software, documentation, and all that. And then we have a for-profit side, which is the hardware. So in a sense, we give away the bits and we sell the atoms. And this is called open source hardware. And it's a lot like Arduino and Raspberry Pi and others, MakerBot, the 3D printer. These are all examples of open source hardware. So we're part of that world. And there's a lot of tricky things about it, licensing and liability and et cetera. And we're navigating our way through it. And we're not doing it all perfectly. But this is, I think, an exciting opportunity to apply the web's innovation model to industries as important as aerospace and manufacturing. This is the cover of Make magazine, which is sort of the Bible of the maker movement, which we're part of. And I just wanted to sort of tell the story of this guy here. They did something on drones last year, and this is Jordi Munoz. So in 2007, when I got started, Jordi was also getting involved in this stuff. He didn't know about me, and I didn't know about him. And he was flying a helicopter with a Wii controller and Arduino. It's really cool stuff. I didn't know about him. He thought he was the only person in the world doing this. He Googles, he couldn't find anything. That very same week, I was setting up DIY drones. So on a Wednesday, he Googled, didn't find anything, designed his Wii controller, for the helicopter. The next week, he Googles again, and he finds us. In that week, I'd set up DIY drones. He finds that he's one of the first, 1,000 people who signed up, and he posted a video of him doing it. And then he posted his code. And I'm like, this guy's awesome. He knows everything I want to know. I must work with him. And eventually we did some projects together. We did a blimp. We did for one of our first autopilots. And I said, it's time to start a company. I got a day job. Will you start a company and run it and call it 3D Robotics? And he said, sure. And I said, well, I've never met you. Can you tell me a little something about yourself? And it turns out that when he first came online, when he first got started this, he was a 19-year-old living in Tijuana, just graduated from high school. Today he's president of a multi-million-dollar robotics company running pick-and-place lines in 2 factories and huge teams of engineers. Still hasn't been to college. But this is the amazing thing. This is what the web's innovation model does, is it allows you to find the best people regardless of what their qualifications or CV or education was. And what I love about our community is that it's got loads of PhDs and it's got loads of kids. And it's got loads of people who work for tech companies, and it's got loads of people who don't have anything to do with tech by day at all. And they all have something to contribute. So when we got started, making stuff, I began with my children putting together a blimp kit. And this is us putting together our first, I have 5 kids, these are 3 of them, and this is us putting together a kit. And this is how it started. Very hobbyist, very makery. By the way, lesson from this, do not put a 6-year-old on quality control. Did not work out so well. The customers were particularly unsympathetic when you explained the reason it was missing parts is that a 6-year-old put it together. So this is the way we got started. That's us 4 years ago. This is Jordi with his first garage. That was him 2 years ago, and this is like 1/10 of one of our 2 factories today. That's what's possible today. These are pick-and-place machines and reflow ovens and stencil printers and CNC machines in the back. It is just amazing what you can do almost overnight when you've got 24-year-olds, running it. Because what 24-year-olds don't know, they don't know you're not supposed to be able to do this. They don't know you're supposed to have degrees in industrial engineering. They don't know that you're supposed to have qualifications. They don't know any of that. All they know is that it's out there. So they all go on Google, they go on eBay, they just do it. And what Jordi taught me, so you would have thought that when the editor-in-chief of Wired magazine partners with a 19-year-old from Tijuana, that basically I teach him everything. And it's exactly the opposite. I taught him nothing, right? Today I was explaining exactly how a performance review works, but that was the only thing. He taught me about Arduino, he taught me about Kalman filters, he taught me about sensors, he taught me about manufacturing, and he taught me about Tijuana. How many people here have been to Tijuana? Okay, when you think of Tijuana, do you think of, throw out some things. What do you think of? Drugs? Drugs, crime, tequila. Right, okay, let me tell you, I'm exactly like you, right? That's exactly what I thought about Tijuana. Tijuana is a city of 6 million. It's more than twice as large as San Diego. All these screens, every screen you see, most of the electronics, the big electronics you buy in the United States are made in Tijuana. It's got one of the most advanced manufacturing sectors in North America. It's safer than where I live. I live in Oakland. Oakland's scary. Tijuana is basically hasn't been scary for, now Juarez on the other hand is scary, but Tijuana has not been scary for like 5 years. I used to live in Hong Kong, and Hong Kong and Shenzhen are this kind of combo, with Hong Kong being sort of developed and where you put the offices in Shenzhen, where you do the manufacturing. San Diego and Tijuana are the same thing. So what these like 20-something Tijuana kids taught me is that Mexico was the secret to bring manufacturing back to North America. Mexico graduates more engineers every year than the United States, and a lot more electrical and production engineers, which is what we hire. Incredible asset. And as a result of having our own manufacturing facilities, we do just-in-time manufacturing. So we can innovate super, super fast because we're not making 6,000 of something and waiting a year for it. We make just small batches, 60, 100 at a time, and we can change the design every day. And that's what the luck of just partnering with a Mexican kid turned out to be the absolute secret to competing with the basically Chinese, innovation machine, which is awesome, but we wanted to provide an alternative. Chinese level manufacturing, but web style innovation with open collaboration and real fast iteration. This is a glimpse of our Tijuana facility now, our second facility. And this one, everything we know about manufacturing, we're now learning from these people in TJ who have these great, electrostatic discharge policies and ISO 9001 compliance, et cetera. And we just got a lease on a lease option on a 50,000 square foot manufacturing facility. 50,000 square feet manufacturing facility in Tijuana costs $2,000 a month. Right, 50,000 square feet is about the size of this room. That's how North America is going to start to compete globally again by using sort of the NAFTA model advanced forward 20 years. So this is really what we learned. We learned about open platforms. Arduino was, I don't know how many people here use Arduino, but Arduino. It's really easy to use. It allows what's called physical computing, which means that regular people can use sensors and actuators, et cetera. It used to be super hard, now it's super easy, and it's open so you can do derivative designs. Electronic manufacturing, super easy. That's a very small pick and place machine, but this basically robotic production is now something that anybody can afford, and then the whole TJ thing has been an absolute mind blower for us. I just want to kind of walk a little bit through how we structure this. I'll be super fast, but I just blew it. Okay, so this is called, the important thing in the open innovation model is getting what's called the architecture of participation. It's like a great video game. Easy to pick up, hard to master. And this is kind of where we set it up. So the question is, how is it possible to do hard stuff with volunteers? And the answer is that you try to kind of incentivize them. Everybody who comes into our project does it for the same reason. It's not altruism, it's not generosity, it's to scratch their own itch. The great thing about an open platform is that if you want a feature that doesn't exist, it's easy to add it. And what our community encourages you to do is once you've added a feature, share it. And if it's good, we'll integrate it into the main code and let everybody have it. And so this means that there's something for everybody to do. Sometimes it's just answering questions, sometimes it's tech support, sometimes it's documentation, sometimes it's bug fixing, sometimes it's bug reporting, sometimes it's adding a line of code, sometimes it's documenting a line of code. And this is basically what happens, is that this is the structure we're setting up now with the dev teams, that it starts with when you do something, we acknowledge it, you give it credit, and we'll send you a t-shirt. People love t-shirts. It's like they get a box that says, you did something valuable to the community, thank you. And then a little bit further, they, when they do a little bit more work, they get hardware discounts, and then they get free hardware, and then they get flown into the dev meeting. At the end of the day, they get equity in the company, which I don't think has ever existed before, the idea of giving volunteers equity in the company. And this is sort of our experiment in turning the web's innovation model into a sustainable business that can do the stuff like compete with the Lockheeds and the Boeings of the world. I talked a little bit about open hardware, but this is sort of the business model. We give away the bits, we sell the atoms. We charge a very simple price, which is whatever it costs, we charge 2.6 times that cost. 2.6 is like this magic number. It allows for two 40% margins. One 40% margin for the manufacturer, that's us, and another 40% margin for the retailer, the distributors. And this is, it's super transparent, and it's a lot less. So an aerospace margin would be like 1,000% or 10,000%. And by doing 2.6%, it's basically within sort of striking distance of the cloners in China, and we have lots of them. But still, so this is how we can sell this. This is like $140, and if you buy it with the GPS, the power module, et cetera, it's $180. And the cloners would be about $90, or actually the cloners are about $50 cheaper than us. And so what that $50 difference allows for is distributors, retailers, a really sustainable ecosystem of businesses around this, but it's so much cheaper than the closed source professional ones that cost like thousands of dollars. So we think 2.6 is sort of the right model, and as our production costs go down, we just lower the prices accordingly. The way our designs are all licensed so that anybody can use them, and they can even compete with us. They can use them commercially and sell against us. We don't love it. We wish that they would do a little innovation, do what we call a derivative design, which is improve on the design. But if all they do is just copy it, okay, we can handle that. How do we compete? And the answer is we're just going to innovate faster. We have one thing the cloners don't have, which is the community. The community is built around this, and the communities are really great. The community combined with just-in-time production are really great at innovating. So we'll produce a new autopilot every 6 months for like $0 of R&D costs, whereas a traditional aerospace business would be about $10 million in 6 years for a new autopilot system. So that's what the web's innovation model gets us. Right now, we are not as good as the pros, but we're getting better faster. So our biggest competitor, I think, is DJI, who we have huge respect for. A lot of people out there think the Chinese are just copying. They're not paying attention. The Chinese are doing fantastic engineering, fantastic production, increasingly good at design, marketing, documentation. We take them very seriously. And so we benchmark against DJI, and I would say we are not there yet. But then the next version of code, which we'll release next week, we're going to be very close. And someday we hope to be able to be better than them for a fraction of the price. And we think that model of having an open alternative to the closed source products, where we try to be as good as them, but cheaper and more importantly, community-based, is fundamentally something the marketplace wants. Again, I take our competitors, I take the commercial competitors very seriously. I think there's room for both, an open model and a closed model. And our job is to ensure that the open model is no less reliable, no lower performance, possibly even better performance than the closed one for people who want that. Open source offers a lot of other advantages. It's, again, free and fast R&D. It's actually exempt from a lot of regulatory barriers. So one thing many of you may know is that autopilots are considered export controlled. They're considered basically cruise missile controllers. And so how is it possible that we can ship them, to say nothing of give them away? And the answer is there's an exemption in the export control rules for public domain. Open source qualifies as public domain. Also, we don't create the code. All we do is we, the company, create the hardware, which is just commodity hardware. It's just your cell phone in a different shape. The code itself, which is the smart stuff, is created by the internet, for the internet, on the internet. You download it from like the web. It's created by volunteers. The regulations weren't set up to accommodate this, but the fact that it's free, the fact that it's public domain, means that it finds a kind of a safe place within the regulations to do this kind of stuff. Couple other things. As you know, we fly under the recreational, the non-commercial exemption to the FAA's rules. Under 400 feet, within visual line of sight, away from built-up areas. Again, the biggest aerospace in the companies in the world cannot fly without a COA, Certificate of Authorization, in the United States. My children can fly every weekend, fly real drones because they're flying under this sort of open amateur level exemption. And these other things are pretty self-explanatory, but community-based development is absolutely crucial to what we do, and it's my job to simply structure the community so it continues to grow, so there's a place for everybody, so that people can not only consume, but also create and contribute. There are definitely challenges in this model. As I say, the architecture of participation, getting that model right so it's easy for people to get started, but then ensuring that the quality at the end is as good as commercial ones. Ensuring that you have testing procedures and code review and documentation. Very, very hard to get it right, but we've seen it happen. Linux is open source, Firefox is open source, MySQL, Apache, all these things got the architecture of participation right in the software world. So we're confident that we will get there in the hardware world. We're getting very close, and but it's you know, it's the job that's never done. There are open questions about liability, about exactly where these things fit in the commercial domain. Again, we're giving away the software, so a lot of the usual kind of rules don't apply. How do you ensure, what kind of insurance do you need for this kind of stuff? What kind of FCC clearance do you need? These are all kind of open questions that we're investigating. Also that, we sell a box. This box does nothing. Then you download code from the internet, and then the box does something magical. Who does the support? I mean, my company just sells the hardware. We only support the hardware in our tech support, and yet most problems come from the software side, which is created by volunteers online. How do we explain to consumers that the reason that this autopilot, isn't doing something quite right is that the codes got it wrong, and that the volunteers made a mistake, and that they should be talking to the community, not us? People don't want to hear that. So fundamentally, we need to sort of structure the company so we can do support for the volunteer software. So this is what the Red Hats and the IBMs do. They do support for Linux, and they build businesses around providing support for open source volunteer contributions. So we need to structure our company to do the same thing. Because at the end of the day, customers don't care whether it's open source, and they don't care, some customers do, but most of them just want it to work. And we need to be able to structure this so that we can offer professional quality performance and reliability for something that is essentially a volunteer contribution. And the rest of the stuff is sort of self-explanatory, but building businesses around something where you don't protect the intellectual property is the challenge that we're all going through. This is the world of what drones used to be, and I've kind of done an order of magnitude calculus here. Drones used to be tens of millions of dollars, and they're global hawks. Then they went to millions of dollars with things like Predators. Then they went to hundreds of thousands of dollars with things like the Scan Eagle from In Situ. Then it's tens of thousands of dollars with the Ravens. And that's what the military-industrial complex sees as UAVs. It's basically manned aircraft minus the man. And that's what the top-down approach does. And our sense is, okay, let's keep going. Right now we have sort of drones that cost under $1,000. And there's, to give you an order of magnitude thing, we basically, it's about 30,000 of our APM autopilots out there. I think it's either the first or second most popular autopilots in the world. We sell about 1,000 autopilots per month. So, and we'll do about 20,000 per year. So we'll put 20,000 drones in the air in 2013. Just to give you an order of magnitude comparison, the entire US military fleet of drones is 7,500. So basically every quarter, by mid-year, we'll be putting more drones in the air every quarter than the entire US military fleet. How is this possible? Ours are not better than theirs. The reason is that ours are cheaper and easier and more personal. So that's what a drone that costs a few $100s, and ours are targeted around $500. But let's keep going. What about drones that cost tens of dollars? You know, today this is 170 bucks. Soon it'll be 90 bucks. Then it'll be like 40 bucks. And now drones will cost like $99, and maybe you'll buy them at Walmart. And then, okay, let's keep going. Oops, sorry, I went too far. What about, you know, remember this technology is being driven by Apple and Google economies of scale. What about when this thing turns into a single chip? Now this chip is in your RC receiver. It's in the toys you get. That fundamentally this technology, that's what we know. This technology is getting faster, cheaper, better at a rate we've never seen before. What happens when autonomy, true artificial intelligence-driven sensors, GPS, etc. What if this is just something that's in every device out here? And all that geofencing is every one of these aircraft has the ability to geofence. They have the ability to come home. They have the ability to data log. They have the ability to be autonomous if you want it to be autonomous. How does this hobby change when an autopilot is basically a $10 add-on to the existing RC you already have? That's what we know is the technology is going to enable it. We know that that's possible. We know it's likely. What we don't know is how this changes this room, your life, and then fundamentally the aircraft that our children are going to see in the air every day. So this is sort of what happens when you do the bottoms-up approach to compete with the top-down approach. Lockheed Martin and Boeing, as much as I love them, are not going to get you to the $10 drone. The web model of open innovation will, and that's, I think, what's ultimately going to change the aerospace industry. So I just want to end on this note. There's the IBM PC from 1983. How did that happen? Did that happen by scaling down an IBM mainframe? Did that happen from taking this and making it smaller, better, cheaper? Or did it happen by taking this and putting it in a box and making it more professional? You know the answer. This is the Apple II. Steve Jobs, Steve Wozniak, Homebrew Computing Club. This is where we started. We started making things that were uglier than that, and worse, and a lot worse than that. And right now, we're moving to the IBM PC level, and pretty soon we'll be in the iPhone level. And we've seen this picture before. We see what happens when bottoms-up innovation competes with top-down innovation. The PC changed the world more than the mainframe did. The internet changed the world once it got in the hands of regular people. And I think the future of aviation is to be applying open innovation, the web's model, and basically regular people doing extraordinary things to put autopilots, autonomy, and robotics in the hands of everybody to find new applications that we can only dream of. Today it's a hobby, tomorrow it's going to be an entire industry. And I think it's going to happen with this model becoming smarter rather than the aerospace industry becoming cheaper. I wrote a book about this, about the maker movement, which is what this is part of, the industrialization of the maker movement. As I say, I think this is an industrial revolution. I think this is probably the driver, not just autopilots, but basically the democratization of manufacturing, taking the web's innovation model to physical things. I think this is going to drive the American economy in the next century, and I'm voting with my feet. This is my career. This is what I'm betting my future on, and this is why I'm here today. Thank you very much.
Test. All right, do we have some questions for Chris while we have him? We only have him today, so.
If you have any questions, hold on a second.
A little facetious, but did you ever get your kids interested?
No.
Oh, that's too bad.
Is this still working? I might have to switch to your mic. No, so is this working? My effort to get my children interested in science and technology is a litany of failure. My kids are great kids, but there's not a geek among them. And as you might imagine, this is a little tragic for me. I have not given up, however. I think one of the reasons they're not into it is because I am. It's a little bit of don't do what your dad did. We're having some success with a 3D printer. We've got a MakerBot at home, and the kids use it to make dollhouse furniture and Warhammer figures. And so they love screens. And so any kind of process that starts on a screen, like CAD, like designing stuff, and we use Tinkercad, and then ultimately they can spend time with Dad printing it out and then painting it, that they're willing to do. But they will not go to the field anymore with me. I tried bribing him with ice cream. I don't know. Maybe someday. Yeah, yes, sir.
He's bouncing six others. You could just use that one. Yeah. Is that on? Is that back on? No, it's not on?
Oh, did I bring any books? I did bring books. I think there's a table over there where we have a stack of books. I think, oh, here it is. We have a stack of books. I think there's a show discount, and I will go over there and sign it and personalize it to whoever you want. And apparently they take credit cards.
Technical question.
Yeah,
Regarding the Follow Me feature,
yeah.
dooning or waves.
I'm sorry?
If you're dooning or waves or whatever the case may be,
Yeah.
will the Follow Me feature be able to accommodate the elevation changes that you encounter, whatever the surface is you're on?
Right. So the question is, does the Follow Me accommodate elevation?
So if you set it 30 foot
Right.
and you hit a big wave that's 40 foot, is it going into that wave or is it going to accommodate the...
So it's a great question. The reason we started with water, rather than snow skiing, for example, is that water's a flat surface. It's a 2D surface, and there's no obstructions. There's very few people around, etc. So right now, yes, it absolutely does. The problem is there's a lag. So like, I gave you the example of windsurfing. Windsurfing turns out to be super easy. Kite surfing, on the other hand, is much harder because you kind of swing like 30 feet in the air. So in this case, we're not going to be able to move the copter fast enough. There's like a 1 second latency between the various GPS and communications, et cetera. What we can do is move the camera. So what happens to the position yourself? So one of the things we're actually doing is on the Follow Me box, there's probably going to be there's a rocker, a 4-position rocker. And so when you tell it to come out to you, you sort of say, do you want it to be here, 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 or here? Depending on the wind and the sun, you want to get the right angle. And in the case of kite surfing, the kite's probably going to be, it's going to be, the wind's coming this way, the kite's going to be ahead of you. So you don't want the kite to be obscuring, so you put it over here. So when you like flying in the air, the camera will track you. That's not, it's be a little slow, but we tend to use these wide angle lenses. So there's a half-second delay. The aircraft typically will not track you. So that's for water. For skiing, we're a little more concerned about that because a couple things. First of all, the terrain is very unpredictable. Second of all, you got trees, and third of all, you got other people around. Terrain following is not hard, but it's because we have the topology from Google Maps. But what we're more concerned about is things that are not on maps, unpredictable obstructions, and so we're not going to enable terrain following on day one simply because we don't want people to be unsafe. But water. Oh, the other thing, by the way, is we insist that we've disabled automatic takeoff and landing for the Follow Me function because fundamentally that thing's sitting on the beach. We don't want the props to spin up at some random time. So we make your buddy sit on the beach, take it off manually, put it in loiter mode, and now it's ready for the Follow Me button to be pushed. And when it's done, it returns to loiter mode on the beach, waiting for someone to switch it back into manual and land it when it's safe. Yes, sir, in the back. No, it was you. Yeah. So mid back.
Do you happen to have any of the APMs with you?
This is ready to catch.
Yeah. Cool.
Yeah. So that one's it's got those pins are so you can again it's an open platform. So those pins is you can add sensors, optical flow, sonar. Anything you want, basically. It's open platforms require that you allow people to extend them. We have the optical flow software is ready. We actually have a new optical flow board coming out that has a really awesome chip. It actually uses optical flow, by the way, is a way. Does anybody have a Payard AR drone? Yeah, so you know how when it looks down, it holds its position by looking. Optical flow is what an optical mouse uses. It just looks at the movement of pixels and turns that into a vector. Our new optical flow board uses a camera chip, which has a lot of pixels, and then just moves an optical flow window around the camera, around the big CCD with a fisheye lens that gives you a 180-degree field of view. So that's the PX4 Flow one. But our current optical flow chip is supported on the current board. I think there was a question over here. Yes, sir.
Oh, right here.
Oh, yes, sir.
I know the battery flight time is limited. Do you think it will eventually catch up to the technology?
So, you know, I told you that technology has never moved faster than it's moving in smartphones. LiPos, unfortunately, are the slowest part of all of that. You know, it's really hard to compete with gas for energy density, et cetera. So I think copters are going to be in the sort of 15 to 20 minute range for a while yet. You want more distance or time, you go for a plane. You want more distance and time yet, you go for a gas engine. So, you know, I wish there were a, you know, Moore's law of LiPos, but it's slow progress. Yes, sir.
Well, first of all, I want to commend you that you're sensitive to the fact that to bring manufacturing back to North America and all the social implications. But ironically, what do you think about the fact that your devices now provide the perfect platform for extremists around the world to do evil? What are your thoughts on that?
Yeah, thank you for asking that question. That's an important question, and I want to address that. General purpose technologies, or all technologies, can be used for good and for evil. Personal computers can do wonderful things, and they create computer viruses. You can build a house with a hammer, you can hit someone on the head with a hammer. I think that our responsibility as technologists is to inform the world about what these technologies can do, to inform the regulators and the law enforcement agencies about what they can do, but not to limit the technology themselves. First of all, ours is open source. We could put in, you know, we could put limits in the code that'll say how you can use it and how far you can go, but it's open source, so people can take out those limits. So there's almost nothing we can do to stop people from using it for ill. What we do is we've reached out to all of the agencies, CIA, NSA, Pentagon, et cetera, and we get like a quarterly briefing with the FBI where we tell them what's going on, what's possible. We have a deal, and we've disclosed this to our community, that if we see anybody in our community doing something, talking about uses that we consider dangerous or possibly terrorist-like, we will actually call the FBI and tell them about it. When the FBI gets in contact with me, which they sometimes do, we will point them to anything that we see. Now, we don't know very much about our users. All we know is their email address and their IP address. But we will give that to the FBI. We've been very transparent about this. That what we want to do is we want to bring this behavior in. We want to bring UAV use into the public light. We want to sort of shine a spotlight on what's going on out there to inform those who are trusted with protecting us about what's possible. So rather than limiting the technology and pushing it underground, we illuminate the technology, make it really easy for the agencies to see what's going on, to let them do their job to protect us. So in a sense, what we believe in is preventing the bad use rather than the technology itself. And as an open platform, there's actually nothing we could do about it. And I think this is largely the Silicon Valley model. You know, we don't lock down computers so they can't be used for ill. We just prosecute people who do use them for ill. So someday somebody's going to do something bad with our technology. We know that. But we would like to believe that by having so many eyes on the use of the technology, that other cases will be spotted ahead of time, and that you know, the law enforcement people can jump in on it very, very quickly. So we take our responsibilities to inform the government about what's going on very seriously, and you know, I fly to Washington all the time to brief them on this. And so far they've been appreciative and supportive of what we do.
Hi there. I'm concerned at what level the FAA is going to interfere with this technology. Myself, I flew full-size helicopters for 35 years and 17,000 hours, but this is not only fun, but to me it looks like a good chance to make some money now. Yeah. But I guess I'm the exception more than the rule.
No, I hope you're the rule. I hope you become the rule.
Well, nobody's going to go spend $40,000 to get a commercial helicopter license.
Yeah.
And then go out and fly toy helicopters. They're going to go make a living with it.
Right.
And so I'm concerned about what the FAA is going to do to clamp down on everyday John Doe, say no, you can't do that.
Yeah.
We don't understand it, so you can't do it.
So this is a question about the FAA regulatory process and the introduction of commercial use in the national airspace. As you know, I think we're going to have a briefing tomorrow on the FAA, on the current status of that regulatory rulemaking process. As you know, Congress has given the FAA a mandate to bring commercial use with certain restrictions into the national airspace. We would like to enable a huge industry of people applying this technology in various verticals. Let me just give you one example, agriculture. We have a team right now who are working with our technology in Davis who are just tromping around wheat fields all the time. So when people think about drones, and I shouldn't use the word drone, and I know they're UAS or UAV, but common language calls them drones. When people think about drones, they think about, manned aircraft-sized predators, things like that in the sky, cameras, etc. I think what's most likely is they're going to be driving around farm fields around here and see small airplanes and quadcopters just flying around doing crop surveys, maybe even crop dusting, like a crop duster today. You actually don't even need infrared, just an optical. It turns out farmers know almost nothing about their crops. Now, I'm not a farmer and I'm probably overstating, but basically it's very hard to get a full holistic view of what's going on everywhere on your farm. Farms are big, it's hard to get to them. You've tried to walk through a cornfield, you know it's not easy. And so what they do is they sample, they spot check and that kind of stuff. What they really want is an overhead view. Actually, even just optical, even in the visual spectrum, it's fine. Farmers are really good at knowing that brown is bad or that, this color is not what they want to see. What they don't have is a daily or weekly, a view of their entire farm. And so we've been doing these experiments, and as a result, in the absence of knowing for sure that there's no wheat blight in the farm, they end up using too many herbicides, too many chemicals, too many herbicides, too many fungicides, too many pesticides, in case something bad's happening, because they don't know if something bad's happening. You put a drone, and we're talking about a foam plane about this big that you just throw out the window. It's automatically programmed to do a kind of lawnmower pattern. The data is then stitched together, and the farmer then looks, basically throw the drone out the window, have breakfast. By the time breakfast is done, you've got an aerial view of your crop in high resolution, and you're like, looking good. Or you're like, whoop, brown patch, got to go check it out. And that kind of information allows us to use less chemicals, it's cheaper, it's just a better thing all in all. That's a great example of a commercial application. And there are some of our friends from the agricultural world are here today. It's a great example of a commercial application which is not competing with man. This job is not being done at all right now. This is a way to kind of create industries, create jobs by using autonomy for what it's good at, which is jobs that are really boring and jobs that are just too, you can pay someone to do it right now, but it'll cost $1,000 an hour. This is a way to use autonomy to do cheap access to the sky to create industries that don't currently exist.
Great job. You created an awful lot of questions in my mind. How would we, in the AMA, how are we going to look at the level of autonomy that we're going to apply to our aircraft? We understand now that we can buy receivers with integrated circuits in them for stabilization. Horizon just released theirs.
Yeah.
Obviously, we're going to be able to take pilots now and allow them to go out in the field and be able to do maneuvers they couldn't do in the past. They're going to be doing more so. At what point will we distinguish how far we're going to go? Are we going to be looking at the future of modeling, incorporating us into flying and programming our flight and sitting out there and say, Jesus, this is a great job, and that's going to be the challenge for me in the competition? Or are we going to be saying, well, I'm going to stop maybe halfway, and now I'm going to be able to do those roles that I always wanted to do. I'm going to set my level, I'm going to go across the field. What I'm looking at and trying to understand is what challenges can you recommend I do as an AMA officer? And of course, what are some of the decisions we're trying to make from our board of directors is how do we go about this? How do we work with you and how do we work with the FAA to create not only at our NATS competition, so we increase STEM classes and all that. You've blown my mind here and created too many questions for me to keep going on. But
well, those are great questions. And by the way, thank you for asking. I never get that question because I'm usually talking to like robot people, and they don't think about the kind of stuff you're talking about, which is, integrating this into the hobby. Okay, so here's what we know. We know that, as you say, this box will soon be a chip that's in every one of these. And we know that chip will do the geofencing, it'll do the return to launch. We also know that all those acrobatics, I know we're seeing some amazing demos out there. it's just a button. There's no, robotic or scripted acrobatics is simply it's a trivial, software function on top of this already. So given that robots fly planes better than people fly planes, and given that they can do things that are impossible for people to do, what is the role of the hobbyist? What's the role of the pilot? Well, initially what we're doing is we're treating it as a STEM project, which is there's a way to teach engineering and programming and robotics, et cetera. So we're going to be launching right now, problem with airplanes and the copters is that they're a little bit dangerous, especially for like high school and middle school students, and they typically need to do it outside. So it's weather issues and some FAA issues and safety issues, et cetera. We're going to be launching a blimp, an autonomous blimp. We started with an autonomous blimp a couple of years ago, and by autonomous I mean it does what's called SLAM, simultaneous location and mapping. It navigates outside of a GPS route, so you don't have GPS inside. So it navigates inside based on its own sensors. The problem is that we didn't have a good way to do that. In our new one, we're using this optical flow technology that we're talking about, which is basically cameras. It's going to cost under $100, and so and blimps are wonderful. They're like whales. They're really beautiful. They're slow. It doesn't hurt you. They sleep on the ceiling. Like at night, they sleep on the ceiling, and you come in, and they bring them down. So they're natural flyers, and so we think that's a great way to teach kids about aerial robotics. But I mean, it's a great question. So right now, our drone competitions, and Lucian Miller and others are doing the multi-copter rodeo later this year, and we're going to have a drone competition there. Right now, the technology is challenging enough that simply programming it is the competition. But when it's as simple as, a chip that's pre-programmed with every acrobatic you can imagine, what's the competition going to be then? I don't know, but I count on you guys to figure it out. Yeah.
I think, the exciting thing is that we're not going to go backwards. If we just look at the helicopter people, when helicopters started 5-10 years ago, and we couldn't even bring a helicopter to become stable, and all of a sudden, now we can go in a store and the guy puts it up in the air and it stays there. So the problem that I'm seeing and feeling is that we're the new people that are coming into the AMA, the people unlike me, they're going to come in and they're going to buy now equipment that's going to give them these features, and they're not going to go backwards. So the hobby and the way we see, we've reached a milestone, especially with fixed wing aircraft now. This happened in helicopters. Look backwards, guys, because now we're going to go from where the helicopters were to where the airplanes are, and now to incorporating what you have, which is going to make a whole new pilot. And the challenge will be to see how we can have that guy still enjoy whatever we can offer as value propositions to all of you out there, because it's still part of a hobby. I know I'm still going to want to fly my plane manually, but I want to also be a 3D flyer that I never could be before.
So, I think that the good news, so the bad news is that you don't have to have skills to fly anymore. The good news is that you don't have to have skills to fly anymore. So it's what you might see is that people come into the hobby not because they want to pilot, but because they want an aerial view of something. They think of it like, a Google Maps, experience, or maybe it's just like, look at the GoPro videos out there. It's a YouTube. Maybe YouTube is the biggest driver of the RC hobby in the future, because we get advantages we never could have had before, because the piloting part was too hard. So I think when you think about what we do is basically turning this plus a GoPro is an aerial imaging platform, and as a way to kind of give a GoPro camera wings, that becomes a very cool, exciting thing for a generation we probably want to bring into RC. Not in the same way that, it's coming in for a different reason, but I think it is a reason. Probably, yeah, sir, back in the back.
I saw a screenshot of a program you could use to administer on-the-fly updates to your flight pattern without having to reprogram the board on the grounds. Is that something that's available today, or is that a proof of concept?
So was it this screenshot?
Yeah, that one.
Yeah, that's called Mavalous, M-A-V-A-L-O-U-S. And you can just Google it right now. You can see a demo on the web as it is. It's basically it's an HTML-based ground station, so it will render in any browser on any device. And what our box does is it just takes the telemetry stream from this, and which is so the problem with Wi-Fi is the range is quite limited. So we have our own radios called the 3DR radios, which have a range of about 2 miles, and they do the telemetry stream, and the box then converts from the 3DR radios to Wi-Fi, so you can connect to the box on any device you have, and then the box renders the ground station in HTML, so it works on every browser, anywhere. So that's basically the way we allow you to use the drone without RC. You don't even need a laptop.